Is it audible to all?
Yes, sir.
Okay. Good evening to all. Let's start the session. Engineering mechanics. Today we can discuss some introduction to engineering mechanics. See here. See, engineering mechanics. Introduction to engineering mechanics. This is class 1. Okay. First we can discuss what are the different contents in this particular engineering mechanics course. 1 minute. Video required. Fine. See here. First, let's have a look on the contents. See, introduction to engineering mechanics, system of forces. In this system of forces, we need to discuss parallelogram law of forces, cosine rule, sine rule, resolution of force method, Varignan's theorem, principle of transmissibility, support reaction calculations in beams. Here, what is the idea here is, first we need to focus on the resultant system of force. Resultant system of force, we know that square root of sigma fx whole square plus sigma fy whole square. Okay, or else we generally call it sigma h whole square plus sigma v whole square. Okay, so resultant system of force. First we need to calculate the magnitude. After that, direction alpha. Then line of action of the resultant force. Line of action. Okay. So to determine the magnitude and direction, we should apply parallelogram law of forces, cosine rule, sine rule, resolution of force method. These 4 methods used to determine magnitude and direction of the resultant force. After that, how to get line of action by using Varignan's theorem and how to transform the forces we can discuss in this particular portion. Take it? Understood? Are you able to follow? In this session, we can focus on the complete introduction to engineering mechanics course. What is meant by engineering? What is meant by mechanics? What are the different fundamentals required? That part we can discuss in this particular session. Again, here, have you heard about this parallelogram law of forces? You studied it in intermediate. Cosine rule also done. Okay, sine rule, resolution of forces. Most of the things, all are fundamentals. You already covered it in the JEE mains. So in the intermediate level, plus 11. Plus 1. Next, free body diagram for system of rulers. So you should, by end of this course, you should become expert in drawing free body diagrams. I will tell you what are the different rules to be followed to draw free body diagram for system of rollers.
So screen is sharing, sir.
1 minute. I think something happened. I'm not able to share the screen. Fine. Now, is it visible to you?
Yes, sir.
Okay. So in the online, generally, we need to have some patience. Okay. Slowly, you will get complete content. Okay. No need to worry about the content. Have some patience and then comfortably sit in front of the computer. That is very important. All had dinner? All done, right? Anirudh, Madan, Muthu Sai Kiran, Sai Charan, Shanmukha Priyan, Yogasri. Okay, all had dinner?
Yes, sir.
Okay, so you can sit comfortably, right? Okay, so have some patience, you will get complete content, no need to worry. Okay, so my plan here is we need to cover most of the engineering mechanics concepts by using free body diagrams. Okay, so you will get to know the importance of free body diagram by end of the chapter. Okay, total end of the engineering mechanics. So I think if you become expert in drawing free body diagram, you can easily get minimum 6 to 8 marks in GATE. 6 to 8 marks. How to implement these particular logics in some other courses, how to solve the problems, how to apply the moments. Okay, na? So then you can easily get 8 marks in GATE. Total mechanics is covered by drawing free body diagrams. Okay, you will definitely become expert in drawing free body diagrams. Next, here in this particular system of forces chapter, we can focus on the moment of a force about a point. This particular statement is very, very important. Moment of a force about a point. Okay, you are in position to apply algebraic sum of the moment of all system of forces about a particular point. Moment of a force about a point. So you will be spending around 1.5 hours on this particular line, and then different forces will be acting on the system. How to determine the magnitude and direction of the resultant force. Magnitude and direction of the resultant force. How to convert system of forces into resultant system of force, resultant system of force into force couple system. That part we can discuss in system of forces. It's a big class. I think it may take around 2 lectures to cover system of forces. Okay, today's session you will be focused on the only introduction to engineering mechanics. Free body diagram for system of rollers. You know, right? Different rollers, roller obstacle problems you have seen. Okay, so complete statics part. This is nothing but statics. Complete statics. What is meant by statics? Tell me. What is meant by
Force is
statics?
applied under the rest conditions, sir.
No. Actually, statics is nothing but system of analyzing that particular system which is at rest. Okay, so statics is nothing but statics is a branch of classical mechanics which deals with the study of behavior of the bodies with the state of rest. Okay, so in this particular statics, you will be having free body diagram for system of rulers. How to analyze system of rulers. Next, friction part. Okay, analysis of stresses. Okay, up to here we can say this part up to stresses. Complete thing is nothing but it will come under static syllabus. Understood now? Friction also. Here also you will be discussing about statics only. All problems are in rest only. Okay, friction we can discuss. And then analysis of stresses. It is one of the important topic in the engineering mechanics course for both mechanical and civil. Okay, we can expect 2 marks in, I think everybody knows, 2 marks for sure from analysis of stresses. Okay, from here you will be getting 2 marks in GATE. That is for sure. Free body diagram for system of rollers. We can expect if question came now, we can expect 1 or 2 marks here. 1 mark. This part is completely fundamentals. Okay, so you will be using these principles in some other courses. Okay, so here this particular cosine rule you will use in theory of machines. Okay, sine rule and velocity analysis you will be using sine rule. Okay, so and then balancing of forces, this particular resolution method is useful. Varignon's theorem, how to transform the forces in the beams. Okay, these all are completely fundamentals. You should be strong in the fundamentals. That is the basic agenda to discuss system of forces. Okay, and then after drawing free body diagram, you will be applying moment of a force about a point. You will become expert in this particular statement, moment of a force about a point. It is very, very important. After that, friction, we can expect 2 marks in friction. Not alone friction, I think a combination of questions will be coming in gate. Okay, write down complete contents. Slowly we'll go into deeper. Parallelly, you can note it down. Okay, next, see here, kinematics of rigid bodies. In this kinematics of rigid bodies, introduction to kinematics of rigid bodies, plane motion, pure rolling, projectiles we need to discuss. Pure rolling is very, very important. What is meant by rolling? Tell me. What is meant by rolling? Anyone? What is meant by rolling? Rolling is the combination of both translation and rotation. Okay? So you need to analyze when the roller is rolling.
For example, tire rolling, sir.
Yeah, actually, yeah, of course. All tires are rolling on the road. Okay? Car tires. Okay? So all car tires are rolling in the sense it is a combination of translation and rotation. Translation and rotation. It is having both translational kinetic energy, rotational kinetic energy. Okay? And then you need to incorporate translating velocity and rotating component of velocity. It's a big discussion. Instantaneous center. Okay, in this particular pure rolling, we need to discuss instantaneous center method. Instantaneous center method. Okay, so it is the, I think we can relate with theory of motions. Okay, so by using this, we can do velocity analysis. Velocity analysis. It is very important. Instantaneous center method. Projectiles, everybody knows. Okay, you already studied this part in the intermediate. At least what is meant by projectile, you know, na? So here, cricket. So ball will be following the projectile motion, and then here we need to analyze that particular complete projectile motion. Okay, so that is projectiles. What is meant by kinematics? Tell me. What is meant by kinematics? Kinematics is the branch of classical mechanics which deals with the study of motion of the rigid bodies without considering causes of motion. That is force and couple. Okay, so understood na? Without considering causes of motion. Most probably here we will do acceleration analysis and velocity analysis. Okay, so both you will be doing velocity analysis in pure rolling, acceleration analysis in pure rolling. Next, kinetics of rigid bodies. It is one of the scoring chapter in engineering mechanics course. Here you will be getting introduction to kinetics of rigid bodies, D'Alembert's principle, work energy method, impulse momentum equation, collisions, in that law of conservation of momentum, law of conservation of angular momentum, and then law of conservation of energy. Okay, it's a big chapter. You will be spending around minimum 10 lectures required. More than 10 lectures required to complete kinetics of rigid bodies. It is the complete, I think, so it's a complete package. So you will be getting, you need to improve all the fundamentals to study kinetics of rigid bodies. In before chapters, here, from here you will be building fundamentals like free body diagrams, how to draw free body diagrams. Finally, we'll apply entire concept in the kinetics of rigid bodies. Okay? So what is the weightage for kinematics of rigid bodies? We can say 1 mark we can expect for sure. Kinetics of rigid bodies, D'Alembert's principle, work energy method, minimum 4 marks you will be getting. Nowadays, around 9 marks weightage is given to engineering mechanics in GATE. Minimum around 5 to 6 questions are coming in each think morning and afternoon paper. Na? In both the papers, we can expect minimum 9 marks in engineering mechanics. It is nowadays they are giving more questions in engineering mechanics. So main idea here is you need to improve your fundamentals, and I will make most of the concepts very simple in the sense we are having some good logics to apply. Once you become expert in those applying the logics, now, so you will feel comfortable to solve the problems. But only thing here is you should have some patience. Okay, na? Understood? Have you written the contents? D'Alembert's principle. It's a wonderful principle actually. D'Alembert's principle. You will be using this D'Alembert's principle in theory of machines. Okay, na? So it's a thermodynamics also we use D'Alembert's principle. Okay. Work energy method, impulse momentum equation. Where we use impulse momentum equation? Tell me. Impulse momentum equation. Where will we use? Pipe bend problems and impact of jets. How to apply impulse momentum equation in pipe bend problems. Pipe bend and impact of jets. Clear? How to apply impulse momentum equation in pipe bends and impact of jets. Okay, so law of conservation of linear momentum. This is nothing but linear momentum, angular momentum. This is very, very important. Every year one question is coming in GATE. 2 marks. Clear na? So how to apply law of conservation of angular momentum. Here law of conservation of energy, obvious, you will be getting 2 marks here. It is very, very important. Okay. So 1 minute. It is very, very important. Law of conservation of energy. Okay. So this is the syllabus. After that, we will be discussing about moment of inertia. Moment of inertia in the sense mass moment of inertia, area moment of inertia. Finally, simple harmonic motion. Then we can start vibration course. Okay, na? So SHM is the funda to understand vibrations in the area of machines. How many of you from civil department? How many of you from civil? Anirudh? Anirudh, are you from mechanical or civil?
Mechanical.
Madan?
Mechanical, sir.
Muttusai? Can you hear me? Okay, mechanical. All are mechanical. Rishika? Mechanical.
Civil, sir.
Okay, you are from, what is your name? Okay, civil. One from civil. Okay, no issue. Okay. Yoga Sri and Okay. Shanmuga Priyan, civil. Good. Okay, these all are these all are contents actually. Have you noted down all contents? Introduction to engineering mechanics, system of forces, what are the things need to be done in the entire engineering mechanics course. Here, most of the content will be completed by drawing free body diagrams. Today also we can discuss for some time how to draw free body diagram for different systems. I think system of blocks. Then you will get to know. Slowly we'll habituated to draw free body diagrams and applying D'Alembert's principle, how to apply work energy method, how to apply impulse momentum equation. Okay? So if you attend all the lectures, you will improve fundamentals. Then you will feel comfortable in the fluid mechanics course, theory of machines, and strength of materials. That is the main idea for taking engineering mechanics course at the beginning. So first I will take this engineering mechanics. You will be giving all fundamentals required to cover this particular fluid mechanics, strength of materials. Then Theory of machines, strength of material, fluid mechanics. That is the thing. Clear now? Understood? Understood? So you should improve your fundamentals. That is the big drawback to the student. Okay. Let's start the session. Engineering mechanics. Okay. So I generally start with the definition of the course. What is meant by engineering? Tell me. Anyone in the class? Most of the people doing engineering, na? Of course, you are doing engineering. Tell me the definition of engineering. Anyone? What is
solving a real-time problem?
What is meant by engineering first? Tell me.
So solving real-time situation problems.
Yeah. Engineering is an application of mathematical, social, economical principles are used in order to give a technical solution to the practical problems. See here, engineering is an application of, have a look on this, mathematical, social, economical principles are used in order to give a technical solution to the practical problems. That is machine design, power generation, transportation, design of softwares, so etc. Here, the main idea, the main role of an engineer is to give a technical solution to the practical problems. To give this particular practical problem, you should have mathematical fundamentals. You should be strong in the mathematics and the social issues and the economical issues. Okay, now industrial, everything. By taking all into an account, you need to give a wonderful technical solution to the practical problems. That is the main key to build the industries. Understood now? First, these people look into customer requirement, and then how to fulfill his requirement. Okay, by that so many products introduced. Okay, the back end person is nothing but engineer only. Okay, understood? That is why you people are doing 4 years B.Tech degree. So why 4 years? Tell me. You should be strong in all mathematics. Okay, now mathematical fundamentals and technical theorems, so many things, equations you build. Finally, how to use that to give a technical solution to the practical problems. What about mechanics? Tell me. Mechanics is the branch of science which deals with the study of motion of the rigid bodies with the state of rest or motion with and without considering causes of motion. Remember this particular definition. Okay. Mechanics is nothing but study of motion of the rigid bodies. One more thing I want to tell you. In engineering mechanics, all bodies are assumed to be rigid bodies. What is meant by rigid body? Tell me. What is meant by rigid body?
Fluid is applying at the fixed position.
My face is visible to you?
No, sir.
What happened? Okay, fine. No issue. Clear? Yeah, tell me. What is meant by rigid body?
So fixed position, sir.
No. What is meant by fixed position? I am asking about body. You are telling position. Okay. What is meant by rigid body? Define rigid body. Anyone?
So it cannot regain its original position.
No. No deformation with the application of infinite force. Even you apply infinite amount of force on the rigid body, there is no deformation. Okay, now engineering mechanics is nothing but mechanics of non-deformable bodies. Okay, so what is the difference between engineering mechanics course and strength of material course? Tell me. In engineering mechanics course, when you apply a load or when you apply a force on rigid body, it will move. Okay, so what is the motion of the rigid body? You will be discussing in the engineering mechanics. But in strength of materials, when you apply a load on the body, it will deform. Okay, deformation. Due to deformation, strain will be coming. Due to strain, stresses will be induced in the component. That complete analysis is nothing but mechanics of deformable bodies. ठीक है. Engineering mechanics syllabus ना, that complete part is on what? Mechanics of non-deformable bodies or else mechanics of rigid bodies. Complete rigid body mechanics. All bodies are assumed to be rigid bodies in engineering mechanics course. Is it okay? Is it okay? Study of motion of the rigid bodies with the state of rest. Okay, that is statics. We already know that. Correct na? Correct or not? With the state of rest is nothing but, see, with the state of rest. This part is statics. Clear? Motion means dynamics. Motion means dynamics. With considering causes of motion, kinetics. Without considering causes of motion, kinematics. Okay, single line definition. Understood now? Understood or not?
Yes, sir.
Now tell me what is meant by engineering mechanics. Engineering mechanics. Engineering mechanics is a branch of classical mechanics. We already discussed fluid mechanics also, classical mechanics, which deals with the study of motion of the rigid bodies with the state of rest or motion with and without considering causes of motion, that is force and couple, in order to give a technical solution to the practical problems. That is engineering mechanics. This is all about engineering mechanics and engineering mechanics. Okay, so if someone asked you what is meant by engineering, are you able to say? At least you should know the definition of engineering, correct na? So because you are spending 4 years of valuable time to get B.Tech degree, at last, if you are not able to define what is engineering, okay, so people will feel bad. They won't feel bad. Directly, they will laugh. Okay, so you should know what is engineering and mechanics, engineering mechanics. Clear? Now, engineering mechanics. Here, we need to classify engineering mechanics course. Overview of the complete engineering mechanics. Okay, so we can divide engineering mechanics into mechanics of solids and mechanics of fluids. Mechanics of fluids, nothing but, tell me, what is mechanics of fluids? Fluid mechanics, na? Mechanics of fluids is nothing but fluid mechanics. Next, mechanics of solids. In that mechanics of solids, you'll be getting mechanics of deformable bodies. In that mechanics of deformable bodies, statics, dynamics. Dynamics again classified into, tell me, kinematics.
Kinematics and kinematics.
Kinematics and kinetics. Kinematics and kinetics. Mechanics of deformable bodies classified into, anyone tell me? Mechanics of deformable bodies means theory of plasticity and theory of elasticity. Theory of elasticity is nothing but strength of materials, so-called strength of materials. Strength of materials. Theory of plasticity means metal forming. Metal forming. All metal forming calculations are done in plastic region. All strength of material calculations are done in elastic region. Okay. So here, but in your B.Tech na, India, all India na, all are preparing for GATE. Okay. So in the GATE syllabus, we are taking this part as engineering mechanics course. Understood? This is engineering mechanics course, but all over world na, people are calling like this. Engineering mechanics is nothing but mechanics of solids and mechanics of fluids. It's a game with fluid and solid. Okay? In this mechanics of solids, mechanics of deformable bodies, mechanics of non-deformable bodies. Here you will be getting non-deformable bodies. 1 minute. Here non-deformable. Here you will be getting non-deformable bodies. This is mechanics of rigid bodies. Here, mechanics of deformable bodies. Understood now? What is engineering mechanics and the different classification? Here, fluid mechanics is a big course, complete thing. We are discussing in offline. Okay. So, how many of you attending offline classes? That fluid mechanics. How many of you attending fluid mechanics classes? All are attending, na? Anirudh, Madan.
I am doing online, sir.
Complete online. Madan?
Yes.
Madan?
We do online, sir.
Okay. All are online now. Fine, fine. Okay. No issue. So, are you feeling comfortable? Comfort is very important in online. Why? Because total 1.5 hours you need to sit in front of the computer. Okay. So, I think we can make good PPTs and projection will, at that I can give you the assurance. Okay. So, we can do good job. No need to worry. Okay. If you have any doubt, feel free to ask. Understood? But have patience. That is very important. Okay. This part you understood? Engineering mechanics broadly classified into mechanics of solids, mechanics of fluids. Okay. Again, mechanics of solids classified into mechanics of non-deformable bodies. This is so-called mechanics of rigid bodies. This part is nothing but mechanics of rigid bodies. Mechanics of rigid bodies. Okay, so when you apply a load on the body, it can't deform. Okay, negligible deformation under the action of infinite amount of force. That is called rigid body. Rigid body is nothing but negligible deformation. Mechanics of deformable bodies means total strength of materials. Na? You played game with deformation, strain, stresses. That part you discussed in the strength of materials. Generally, that is a theory of elasticity. Theory of plasticity means metal forming course. I think production faculty can handle this. Production faculty will be discussing metal forming. 2 marks weightage in gate. Next, mechanics of fluids, nothing but fluid statics, fluid dynamics. That's it. This is the broad classification of engineering mechanics. Now, here tell me, you discuss engineering mechanics is nothing but, see here, solids and fluids. Anyone tell me what is the difference between fluid and solid? Actually, introduction to engineering mechanics, actually why I build this particular class means just to give some funda to clear the interviews. Okay, so all questions now, most of the questions are popularly asked interview questions. Okay, so now tell me, what is the difference between fluid and solid? Anyone? What is the difference between fluid and solid? Anyone, please respond. If it is interactive, na, you won't feel bored. Okay. So tell me, what is the difference between fluid and solid? First, see the, tell me.
Fluid will deform continuously, sir.
Excellent. Solid?
Will not deform continuously. Instant, I think.
Instant deformation you will be seeing. Fluid is the substance which deform continuously under the action of shear forces. Okay. Solid is the substance which deforms instantly under the action of shear force. Okay. So you will be seeing continuous deformation. Continuous deformation. This is very, very important. You need to use this word. In fluids, it deforms continuously under the action of shear force. Here, instant deformation. Here you will be seeing instant deformation under the action of shear force. What is the reason for that? Tell me. What is the reason for continuous deformation in fluids? Due to presence of, tell me, viscosity. Due to presence of viscosity. Okay? So solids, no viscosity. Viscosity is nothing but wet friction. Okay, so you will be seeing dry friction in engineering mechanics course. Complete dry friction, new viscosity, you will be discussing in the fluid mechanics. Okay, so here see this. I am applying a force F here. I am applying a force here. It is deforming like it is A, it is B, A dash, A double dash, A triple dash. Okay, so B dash, B double dash, B triple dash, like this. Clear now? So this is called continuous deformation. You will be seeing this kind of continuous deformation in fluid, solid. Instant deformation. See here. When you apply shear force on solid, here this is nothing but fluid. This is fluid. This is solid. Clear? When you apply a shear force on, wait a minute, solid, instant
So shear force is parallel force.
What?
Shear force is parallel force now, sir.
No. Shear force is nothing but transverse shear load. Okay? I will be telling transverse shear load. Here, okay. This is the part. If you take, this is the body, or else one bar, you can say. What is this? What is the name of this particular axis? Longitudinal axis. This is transverse axis. Correct now? Transverse axis. This is longitudinal axis. The load which is acting along the transverse axis, that is called shear load. Okay. Vertical transverse shear load is nothing but shear force in beams. That part you can discuss at the last slide. Today lecture only. What is meant by shear load? What are the different loads? Okay. So how bending moment is created? How twisting moment is created? What are the different name of the forces which are required to create bending moment, twisting moment? That part we can discuss later. Okay. Now you understood now. This is nothing but shear force. Shear force is acting along the transverse axis. Is it okay? Okay. Here you will be seeing instant deformation delta. Instant deformation delta. This is phi. Shear angle, and this is equal to shear strain. Next, due to continuous deformation of fluid, rate of deformation will occur. Okay. Due to continuous deformation, rate of deformation will occur. Continuous deformation results rate of deformation. Okay. That is why shear stress is directly proportional to shear strain. Understood now? In this particular fluid mechanics, Newton's law of mechanics. That part will be coming in fluid mechanics course. I think if you know, that would be better. Shear stress is directly proportional to rate of shear strain. Rate of shear strain in case of fluids. Rate of shear strain becomes equal to velocity gradient. Velocity gradient, tau equals to mu into du by dy. Understood now? Understood? This particular Newtonian law, Newton's law of mechanics. This see Newton's law coming from the definition of the fluid. Fluid is nothing but continuous deformation takes place under the action of shear force. Due to continuous deformation, rate of deformation will occur. Rate of deformation results rate of shear strain. That is why shear stress is directly proportional to rate of shear strain in case of fluids. But here, instant shear deformation results instant shear strain. That's it. Shear stress is directly proportional to shear strain. Finally, we'll be getting tau into G5. Okay, these equations are not important here. You are in position to give the difference between fluid and solid in front of the interviewer. Correct now? What is meant by fluid? What is meant by solid? Understood? Understood or not? Are you able to give the difference between solid and fluid now? Anyone?
Yes, sir.
Okay, so it is one of the popularly asked interview question. Next, see this here, that part only. Shear stress is directly proportional to, tell me. In this case, shear stress is directly proportional to rate of shear strain. Okay, rate of shear strain is nothing but velocity gradient. That part we can prove it in viscosity chapter. Okay, fluid mechanics course. Rate of shear strain equal to velocity gradient. Finally, tau equivalents to mu into du by dy. But in case of solids, shear stress is directly proportional to shear strain. Why? Because instant deformation, instant shear strain. Tau equivalents to G phi, modulus of rigidity. That's it. That is the difference between fluid and solid. Next, coming to who is the hero of fluid mechanics? Tell me. Complete. In fluid mechanics, we will be discussing pressure. In solid mechanics, so-called strength of material, stress.
Force.
Stress. Okay. So what is the difference between pressure and stress? Tell me. Anyone? What is the unit of pressure?
Bar or Newton per mm square.
Newton per meter square. What is the unit of stress?
Same, Newton per mm.
Newton per meter square. Now tell me the difference between stress and pressure. What is the difference between pressure and stress?
Pressure will be acting in the internal force, whereas stress will be acting in external.
What? Pressure means what? What is meant by pressure?
Certain areas are continuous applying force.
No. Here, what is meant by pressure? Somebody asked in the interview. Pressure is nothing but generally 100 students attended, all will give same definition. What is meant by pressure? Pressure acting on the surface, okay, is nothing but the magnitude of external force acting per unit area of cross-section. External force acting per unit area of cross-section. But stress is nothing but the magnitude of internal resistance offered by the body per unit area of cross-section. Just have a look on this. External load or external force acting per unit area of cross-section. External load or external force, that is nothing but pressure. Pressure P equivalents to F external force acting per unit area of cross-section. But stress is nothing but internal resistance offered by the body. Internal resistance offered by the body per unit area of cross-section. Okay. So one more good definition for pressure is, see this. You need to start like this. Pressure associated with the fluid molecules. See here. Pressure associated with the fluid molecules. When these fluid molecules strike the surface, velocity of the fluid molecules will changes. Then change in velocity of the molecules come into picture. Due to change in velocity of the molecules, change in momentum come into picture. It results rate of change in momentum. Rate of change in momentum is nothing but force. Okay? The magnitude of this particular force acting per unit area of cross-section is nothing but pressure. If you give this definition, you will definitely select in that particular company. I repeat this. How to give a different definition for pressure? See here. Some particular surface is there. Some surface. Fluid molecules are here. Pressure associated with the fluid molecules. Okay, listen, every statement is important. Pressure associated with the fluid molecules. Okay, when these molecules strike the surface, velocity of the molecules will changes. V1, V final like that. Okay, so velocity of the molecules will definitely changes because these molecules strike the surface. Due to change in velocity of the molecules, change in momentum coming to picture. Correct na? Change in momentum coming to picture. M into delta V. Correct na? Due to change in velocity, change in momentum coming to picture. Rate of change in momentum is nothing but force. Okay, the magnitude of this particular force acting per unit area of cross section is called pressure. Okay, so generally all will explain like this: magnitude of external force acting per unit area of cross section. But we are giving reason for getting this particular external force. Understood? Can I repeat? Can I repeat the statement? This is the
Yes,
surface.
sir.
Molecules, initial velocity. After striking the surface, velocity of the molecule changes. Due to change in velocity, change in momentum coming to picture. Rate of change in momentum is nothing but force. The magnitude of this particular external force acting per unit area of cross section is called pressure. Okay, like this we need to explain in front of the interviewer. Okay, understood? Understood or not? How to give single line difference between pressure and stress? Tell me, single line difference. See, if
Pressure scalar.
I am not talking about physical quantity. I am talking about the difference. Okay, so if someone asked in the interview, you need to give the difference like this. If I pressure you, one guy here, he is your guide, another guy here, you, ठीक है ना? If your guide pressure you, you will feel stress. Correct na? You will feel stress. If I pressure you, you will feel stress. Pressure applied externally, stress induced internally. Okay? So that is the single line difference between pressure and stress. If someone pressure you, you will feel stress. That feeling should come from internally, pressure applied externally. Okay? Pressure is nothing but the magnitude of external force acting per unit area of cross section. Stress is nothing but the internal resistance offered by the body per unit area of cross section. Due to pressure, stress can be induced, but due to stress, pressure can't be developed. Okay, na? Due to pressure, stress can be induced. Due to stress, pressure can't be developed. It is very, very important statement. Due to pressure, anyone? Due to pressure, stress can be induced. But due to stress, pressure can't be developed. Okay, so it is also one of the important difference between pressure and stress. One more good point here. Pressure at a point equal in all the directions according to Pascal's law. Correct na? If you take anything, this is free surface. If you take this particular fluid particle, what is the pressure? Px.
Same in all directions.
Pz. Okay, Px equal to Py equal to Pz. According to Pascal's law. Pressure at a point equal in all the directions. But stress at a point may or may not be equal in all the directions. It depends on the loading conditions. Correct or not? See here, stress at a point may or may not be equal in all the directions. It depends on the loading condition. Correct or not? Tell me. Correct or not? Stress at a point, sometime in under hydrostatic state of stress condition, stress at a point equal in all the directions. In, see this, under hydrostatic state of stress condition, sigma h sigma h, sigma h. Okay? Sigma h, sigma x equal to sigma y is equal to sigma z is equal to minus sigma h. Okay? In this particular case, you will be getting stress at a point equal in all the directions. But remaining cases, stress at a point not equal in all the directions. It definitely depending on the loading conditions. But in case of pressure at a point equal in all the directions. Next, pressure can be measured by using manometers, but stress can't be measured. But normal strain can be measured by using strain gauges. Normal strain can be measured by using strain gauges. How to play the game with strain gauges can be discussed in strength of material course. Next, pressure is a scalar quantity. What about stress? Tell me. Anyone?
Tensor.
Okay, pressure is a scalar quantity. What about stress?
Second order
Stress
tensor.
is a second order tensor. Anyone tell me? What is meant by second order tensor?
So it depends upon some other magnitude and direction and one other tensor.
What? Anyone please tell me what is meant by second order tensor? It is very important. What is meant by second order tensor? Anirudh, Madan, what is meant by second order tensor means? See here, scalar is a zero order tensor. Okay, see here, scalar. What is meant by scalar? Tell me. To represent a physical quantity, only magnitude is sufficient. Understood? Only magnitude is sufficient. What is meant by vector?
First order tensor, both magnitude and direction.
Magnitude
And direction.
and direction. Excellent. Now tensor term
One
K.
more additional term.
Okay, see here. To represent a scalar, some scalars, only magnitude is sufficient. To represent some quantities, both magnitude and direction required. Okay? We have given the names like scalar and vector like this. In tensor terms, scalar is nothing but zero order tensor. Okay? Scalar is nothing but zero order tensor. Vector is nothing but first order tensor. First order tensor. Okay, scalar is also tensor, but it is a zero order tensor. Okay, so in zero order tensor, only magnitude is sufficient. In first order tensor, both magnitude and directions are required. Okay, so in the tensor family, stress, strain, okay, na, both will come under second order tensor. That means to represent stress and strain, only magnitude and directions are not sufficient. Okay? We need more number of quantities to represent. That is why we can call it as second order tensor. Second order tensor. Understood now? How many quantities required? In 3D, tell me.
9.
Okay. So to represent this, sigma xx, tau xy, tau xz. Okay. Sigma here, sorry. 1 minute. Tau, here you will be getting tau yx, sigma yy, tau yz. ठीक है? Here tau zx, tau zy, sigma zz. 3 by 3. Total 9 quantities required. 9 quantities required to represent stress induced at a point. Okay, that is why only magnitude and directions not sufficient. That is why we are going little higher order. What about moment of inertia? Tell me. Moment of inertia, is it a scalar or vector? Anyone? See here, moment of inertia is a scalar or vector? Anyone please tell me? Moment of inertia is a scalar or vector? Moment of inertia is also
Scalar.
second order tensor. Moment of inertia is also second order tensor. How to represent moment of inertia? Ixx, Ixy, Ixz, Iyx, Iyy, Iyz, Izx, Izy, Izz. Okay, but in your B.Tech now, all are symmetrical bodies. That is why you will be having remaining terms of 0. So you are discussing only Ixx, Iyy, Izz. But strictly speaking, total 9 quantities required to represent the moment of inertia tensor. Okay, strain, stress, both are second order tensors. Rotation and image, tell me. Rotation and image. Both are second order tensors. Transformation is a third order tensor. What is meant by transformation? Tell me. Transformation is nothing but you will be getting rotation here, translation here. 0, 0, 0, 1. Okay, it's a combination of both rotation and translation 4 by 4. Okay, transformation is a third order tensor. This is third order tensor. Rotation is a second order tensor. Translation is a vector, first order tensor. Transformation is a third order tensor. These all are some examples of second order tensor and zero order tensor, first order tensor. Understood now? What is this particular tensor business? Understood? Scalar is also tensor, but it is a zero order tensor. Vector is a first order tensor. In that particular tensor family, stress and strain, moment of inertia, rotation, image, all will come under second order tensor family. Transformation is a combination of both rotation and translation. Transformation is nothing but third order tensor. You can represent with 4 by 4 matrix. Next, just now we discussed what is meant by engineering mechanics. Engineering mechanics is nothing but mechanics of rigid bodies. In this, statics of rigid bodies. In the static part, what are the things need to be discussed? Tell me. Tell me. Analysis of rollers. Tell me. Analysis of rollers. And friction also we need to discuss here itself.
Trusses.
Analysis of trusses. Analysis of trusses. Dynamics of rigid bodies, kinematics of rigid bodies, and kinetics of rigid bodies. I think we already discussed, but one by one you will get to know. This is just an introduction class. What are the things need to be discussed in upcoming classes in this particular entire engineering mechanics? What are the things need to be discussed? That part only we are discussing in the introduction to engineering mechanics. Now tell me, what is a rigid body? We already discussed so many times. What is meant by rigid body?
It will not deform, no?
Negligible deformation.
Under the finite load.
Negligible
applying the
deformation under the action of
infinite
under the action of infinite force. Okay? So dynamics. What is meant by statics? With the state of rest. Okay, with the state of rest. Study of behavior of the bodies, study of motion of these particular bodies with the state of rest. Okay, motion. In that motion is nothing but dynamics. With considering causes of motion, kinetics. Without considering causes of motion is kinematics. Clear? I think it is also one of the popularly asked interview question. What is the difference between kinematics and kinetics? Is it clear to all? What is the difference between kinematics and kinetics?
Without the considering action.
Kinematics is nothing but
Branch of
everything. Same definition will be coming. Without considering causes of motion. Without considering causes of motion means, tell me, without considering causes of motion, kinematics. With considering causes of motion,
kinetics.
This is kinetics. So this is, I think, my junior attended IIT Kanpur interview. At that time, they asked this question. What is the difference between kinematics and kinetics? After that, they will go into deeper. Now force. Here, you have seen force and couple now. Force and couple. Now we can discuss about force. What is meant by force? Anyone tell me? What is meant by force? What is meant by force? Please tell me what is meant by force. Force is an action which tries to change the state of the body. Okay. What is the definition of force?
It's an action try to change the direction.
Force is an action which tries to
change direction or location.
Which tries to change the state of the body. Now tell me, what are the different forces you have seen in the market in this particular total engineering? What are the different forces you have seen? What is the basic force? Tell me. Weight, right? Weight, gravitational force. Okay, weight is nothing but, weight is nothing but gravitational force. Correct now? Are you following?
Yes, sir. Yes, sir.
Force is a vector quantity. Vector means first order tensor. Vector means first order tensor. Okay. Weight is having both magnitude and direction. What is the magnitude of weight? What is the magnitude of weight? mg na? Weight of the body always act vertically downward direction. What is the another force you have seen? Tension in the string. Correct now? Are you following?
Yes, sir.
Tension in the string. T is the magnitude. T is the magnitude. What is the direction? Tension in the string always pull the body. These statements are very, very important. Tension in the string always pull the body. Normal reaction. Normal reaction you can represent with either N or R. Normal reaction always act perpendicular to the surface. Correct now? Normal reaction always act perpendicular to the surface. What about another force you have seen? Frictional force, right? Frictional force, inertia force. Okay? Inertia force and frictional force both always act opposite to the direction of motion of the body. Write down this table. So total free body diagram. Okay, you will be playing game with all free body diagram by using this table. Okay, you will be using same statements throughout the course.
Sir. Sir.
Yeah, tell me.
What is buoyancy force? Sir? It is also called as inertia force.
Okay, buoyancy force is different. Okay, in engineering mechanics, okay, if you combine engineering mechanics and fluid mechanics problems, buoyancy force will be coming. But that particular buoyancy force we can discuss in the fluid mechanics course in detail. Okay. But here, these all are popular forces. Weight we need to represent. Whenever string is there, tension will be coming. Normal reaction we need to draw. Okay. So one more statement here I want to add here. At every point of contact or contact surface, two normal reactions will be acting. Both are equal in magnitude, unlike in nature. See this? At every point, at every contact point or surface, two normal reactions will be acting. Both are equal in magnitude and unlike in nature. Okay. So just to give the importance of these statements, just I want to draw free body diagram for the very basic system of blocks. Okay. Then you will get to know the importance of this statement. Okay. What is the first statement? Tell me. Weight. Weight of the body always act vertically downward direction. Tension in the string always pull the body. Normal reaction at contact surface or contact point always act perpendicular to the surface. Inertia force, frictional force, both will be acting opposite to the direction of motion of the body. Okay, understood the statements? You should know the list of forces you'll be using in entire engineering mechanics course. List of forces and magnitude and direction. How to represent these forces in free body diagram. Okay, so then your life will be very cool in engineering mechanics course. This point also additional. Okay, how to use these statements? Just have a look on this. What you have seen here? What are you seeing on the screen?
Person is pushing the blocks.
Okay, so this guy is pushing the block. Okay, block is moving like this. What is the first statement? What is the first statement?
Reaction is acting.
No, go in the flow. What is the first statement? Weight.
Okay.
Weight. How to represent weight?
W.
Okay, you need to represent at the center of gravity G. Of course, this will be G. Weight always act. Okay, this is the motion, acceleration, of course. Weight, okay, applied force P, fine. Now we can start. What is the first statement? What is the first statement now? Weight. Weight always act vertically downward direction. What is the next statement? Normal reaction, right? Normal reaction.
Tensions.
No string, no tension.
Okay, sir.
Whenever string is there, we need to represent the tension. Okay? So at contact surface, normal reaction will be coming. Normal reaction always act perpendicular to the surface. That is normal reaction perpendicular to the surface. What is the last point? At every contact surface, two normal reactions will be coming.
Both are in equal
in magnitude, unlike in nature. Unlike in nature means opposite. Okay? Next, if this particular block, okay, pushing the block definitely move forward direction. Frictional force always act opposite to the direction of motion. Okay, so in that case, this is frictional force. This is frictional force. Always act opposite to the direction. Inertia force also acting opposite to the direction of motion. Okay? But this is called relative friction. This is concept of relative friction. Okay, so free body diagram for the block. This is the free body diagram for the block. FBD for the block. Understood now? You are not focusing on the free body diagram for the floor. That is not your area of interest. So that is why most of the textbooks people are not focusing on the free body diagram for the floor. Okay, but you should follow this particular rules. Understood now? Understood? This is just an introduction class. No need to worry. Okay, so at last now you are in position. You will be in position to draw free body diagram. Just I am giving some idea how to, or what are the different forces you will be playing game with. Okay? So next, you understood this procedure? Even you don't understand, no need to worry. Okay? So you have not at all started system of forces. Okay? Free body diagram, everything will come in line. Here, see this. What is the first statement?
Weight.
Weight. Okay? And tension here. Tension. This is the setup. Now we can start. Weight always act vertically downward direction. Tension in the string always pull the body. Correct now? Tension in the string always pull the body. One tension pulling this body. Another tension pulling this body. Correct or not? Correct or not? Okay. So tension always pull the body. What is that? What else you need to draw? Next statement. Normal reaction always act perpendicular to the surface. At every contact surface, two normal reactions will be acting. Frictional resistance always act opposite to the direction. Inertia force will be acting. Okay. If you want to apply D'Alembert's principle, we can represent inertia force in the free body diagram. That part we can discuss later. Just how to represent the forces, how to draw free body diagram. Okay. Next, here tell me what you have seen. Pushing the block on inclined plane. In that case, this is the thing. Observe. You are pushing the block. Okay. In that case, weight always pushing force. Weight always act vertically downward direction. Next, normal reaction. At the contact surface, two normal reactions. Then frictional resistance, inertia force. It's very simple. Okay. So once you know those statements properly, how to represent weight, how to represent normal reaction, how to represent inertia and frictional resistances, it is very simple to draw free body diagram. After that, see this, pulling the block on inclined plane, same procedure. Okay. This guy trying to pull the block. Weight always act vertically downward direction. Tension, weight, normal reaction, inertia force, this frictional resistance, inertia force. That's it. Understood now? How to apply D'Alembert's principle, work energy method, impulse momentum equation. Okay. How to apply kinematics here. That part will come slowly. Okay. So these all are list of forces. We are discussing about force. Understood now? Just we are discussing force. What is meant by force? What are the list of forces we need to use in engineering mechanics? What are the forces we need to use? Weight of the body, normal reaction, tension, inertia force, frictional resistance. What are the magnitude? Why? Because force is a vector quantity. You should know both magnitude and direction. That's it. How to represent complete stuff in the free body diagram. That's it. Next. Next, see, this block is moving down on inclined plane. Okay, now this block is moving down on inclined plane. It is also very simple. Again, weight always act vertically downward direction. It is moving down. Weight acting downward direction. Normal reaction. Always act perpendicular to the surface. And frictional resistance, inertia force. That's it. Again, how to resolve the forces. That part we are not in that particular position. Correct now? How to resolve the load, that also we don't know. Clear? That part will be coming in the system of forces. How to resolve W. Okay? So one by one you will get to know. Clear now? These all are different forces. Even you are not able to understand how to draw free body diagram, no need to worry. Why? Because you have not at all started free body diagram. Okay? So just I am giving a rough idea to draw free body diagram. That's it. Understood? Understood or not?
Yes, sir.
Okay. So these are next. Next coming to four couple. Okay. How many couples you have seen? Tell me. In entire engineering, it may be civil department or else mechanical department. How many moments you have seen? How many moments you have seen? Tell me. Bending moment, twisting moment.
Twisting moment.
Okay, na? What is meant by bending moment? What is meant by bending moment? Anyone tell me? What is meant by bending moment? Bending moment is the couple which is acting perpendicular to the cross section of the member. Okay. Bending moment is the couple which is acting perpendicular to the cross section of the member.
The couple is two equal and opposite forces.
Okay, na? So now, what are the different forces required to create a bending moment? What are the different forces? Okay, so one load is here, vertical transverse shear load. What is this particular load? Tell me. 1 minute. Now we can see different loads. Okay, to create a bending moment, to equal in magnitude and unlike forces are required. Correct now? To create a bending moment. For example, this is the one component. This is one component. What is the name of this particular load? Tell me. What is the name of this load?
Transverse load.
Axial load. Correct or not? What is the name of this load? Axial load. Okay, along the longitudinal axis. That you can call it as a axial load along the longitudinal axis. This is called transverse axis. Correct now? This is called transverse axis. Whenever a load is acting along this is called vertical transverse shear load. Correct or not? Correct now? Are you following? Are you following or not? Any
Yes, sir.
doubt? Any doubt here? You should know the name of different loads. It is very popularly asked interview question. This is axial load. Axial load. Okay, a load is acting along the transverse axis now. That is called vertical transverse shear load, so-called shear force. You know or not? What is meant by shear force? You have drawn shear force diagrams, bending moment diagrams. Clear? Shear force is nothing but vertical transverse shear load. Okay, one load is acting downward, another load is acting upward. Okay, so to equal in magnitude and unlike in nature. Okay, so what kind of moment is creating here? This is X actually. This is X. This is Y. Okay, so this you can call it as MX now. MX. Are you following? Are you following
Yes.
or not?
Yes,
This
sir.
particular moment is acting perpendicular to the cross section or parallel to the cross section?
Perpendicular.
This particular moment is acting perpendicular to the cross section or parallel to the cross section?
Perpendicular.
This is a rectangular cross section. Okay, na? See this. This particular moment is acting perpendicular to this particular rectangular cross section or parallel to the cross section. This is called parallel to the cross section. Understood? Parallel to the cross section. This is
Perpendicular, sir.
perpendicular to the cross section. Okay? Bending moment is nothing but it's a couple which is acting perpendicular to the cross section of the member. To create a bending moment, okay? So vertical transverse shear loads required. Vertical transverse shear load is nothing but shear force. To equal in magnitude and unlike, vertical transverse shear loads will create a bending moment in the component. It is very, very important. Understood this? How vertical transverse shear loads are creating a bending moment. Okay, so one load is acting downward, another load is acting upward. Both are creating a couple first. That couple is acting perpendicular to the cross section of the member. That is why you are calling that particular couple as a bending moment. Similarly, okay, so horizontal transverse shear load. Horizontal transverse shear load. One load is acting like this, another load is acting like this. Okay, so these two loads are creating a couple, right? Couple, right? Like this only, na? Are you following? Are you following? This kind of couple. This kind of couple. Okay. This couple is also acting perpendicular to the cross section of the member. Okay. So now we can conclude. See this. 1 minute. Here, this is nothing but my. Okay. So this particular couple also acting perpendicular to the cross section of the member. Okay. So in strength of material course, which couple is acting in entire structures, strength of materials? Okay. So entire civil engineering. Which bending moment diagrams you have drawn? Tell me. Case 1 or case 2?
Case 1, sir.
Case 1 or case 2?
Case 1.
Yes. Okay. So all vertical transverse shear loads, so-called shear force. Okay. Shear force will create a bending moment. What is the bending moment equation? M by I is equal to sigma by Y is equal to E by R. So always I neutral axis. In this case, mx by ixx you need to take. Correct or not? Mx by, in this case, 1 minute. Oh, sorry. In this particular case, you will be taking m by I neutral axis, of course. In this case, mx by ixx you need to take. Sigma b by
Y.
Take it, sigma b by y. If it is b, this will be d. But here tell me, E by R. Here tell me,
My
by Iyy. Okay, sigma b by capital X you need to take E by R. Take it. So in this case, y is nothing but d by 2. Here x is nothing but b by 2. This kind of thing you have not seen in the B.Tech. Okay. So most of the loads all are vertical transverse shear loads only. But if they frame question on horizontal transverse shear load, you will face problem. Okay. So distributions you will be getting like this. Distributions, but here you will be getting distributions in the different fashion. Okay. So that part, I think strength of material faculty will be taking care. For time being, we need to discuss what is the difference between bending moment and twisting moment. What are the different loads required to create a bending moment in the bar? Understood now? Understood or not?
Sir.
Okay. So whenever you face an interview question based on this particular bending moment, are you able to answer?
Yes, sir.
Okay. So first they will ask what is meant by bending moment. What is bending moment? Bending moment is a couple which is acting perpendicular to the cross section of the member. Okay. So here, what are the different loads? Then immediately they will ask. To equal in magnitude and unlike vertical transverse shear loads will create a bending moment, and or else to equal in magnitude and unlike horizontal transverse shear loads will create a bending moment. In what manner they are creating, you can show. And then what are the bending moment equations we need to use to calculate bending stresses? Okay? So that part we can discuss later in the strength of material course. Next, twisting moment. Twisting moment is nothing but twisting moment is a couple which is acting parallel to the cross section of the member. Okay? So this is called eccentric. Some eccentricity is there. If the same load is acting here, you can call it as vertical transverse shear load. Correct or not? Okay, so it is acting with some eccentricity, D or whatever eccentricity, E you can say, nothing wrong. Okay, with eccentricity E. Clear? So in this case, to equal in magnitude and unlike eccentric vertical transverse shear loads will create a twisting moment. Correct now? Like this. Is it clockwise? Clockwise only, na? Like this. Okay. It is acting twisting moment T. This is MZZ. No, MZ. Oh, sorry. What happened? This is MZ is nothing but twisting moment or else torque. Okay or not? Okay, so that is called twisting moment. Now we understood, right? What is the difference between bending moment and twisting moment? What are the different forces required to create a bending moment and twisting moment? Is it clear to all? Is it clear?
Yes, sir.
What is the torque equation? T by J equal to tau by R is equal to G theta by L. Why polar moment of inertia is coming here? Tell me, anyone? Strictly speaking, T by IZZ, na? Correct?
Yes.
This is nothing but G theta by L. So IZZ is nothing but polar moment of inertia. Polar moment of inertia. Polar moment of inertia is coming in the torque equation. Now we can see there's kinematics of rollers. Okay, rolling is nothing but just a small idea. Rolling is nothing but, have a look on this. Pure rolling is a combination of both rotation and translation. Translation is nothing but translating component of velocity. Velocity at any point on the disk is same and it is acting in the direction of motion. Rotating component of velocity is nothing but it is like this. It is always act tangentially. R omega is the magnitude. Omega I is the magnitude. This is a small discussion. So what is the velocity G under no slip condition? Okay, velocity at this particular point will be 0. No slip condition. That part we can discuss slowly. Okay, so velocity at center of the roller is equal to omega R. How to analyze this and what is instantaneous center method? Slowly we'll go. How to here translational kinetic energy, rotational kinetic energy. That part will be coming. I think I am done. This is all about some introduction to the engineering mechanics. Next class, we can discuss on the system of forces. Just have a look on the entire session. What are the things we discussed? We can close it.
Sir,
okay? Yeah, tell me.
Sir, I'm not getting about clearly transverse versus longitudinal.
Longitudinal axis and the transverse axis. Longitudinal axis in the sense of one bar you can take. If it is sir. Bar, na? Bar in the sense this is longitudinal axis along this particular length.
Okay, so if it is parallel, now if it is perpendicular, it's
perpendicular to that is transverse axis.
Okay, sir.
So load is acting along the transverse axis. That is called transverse shear load.
Okay, sir.
Okay. If it is vertical transverse shear load. Okay. So in today's class, we discuss some introduction to engineering mechanics. It is done. Tomorrow we can start with the system of forces. In that, first we can discuss resultant system of force. Okay, one by one you will get to know. No need to worry. Free body diagrams. In this session, we discuss what are the different contents. Okay, these all are contents we discuss. Definition of engineering mechanics, classification of engineering mechanics. After that, difference between fluid and solid. So how Newton's law of Newtonian equation and this Hooke's law. What is the difference between pressure and stress? Okay, so why this is second order tensor, that part we discussed. So scalar, vector, what is tensor, zero order tensor, that part we discussed. Then force, what are the different forces we need to study in engineering mechanics, how to represent the forces, to draw free body diagram. We have not started analyzing these systems. Just I have seen rough idea how to represent. That's it. Nothing great here. And after that, you will be applying D'Alembert's principle, work energy method, impulse momentum equation, and law of conservation of energy. So many things we need to do. Okay. So then different varieties of problems and twisting moment, bending moment. This bending moment versus twisting moment. It is very important actually in the interview point of view. So I think pure rolling. Next, I am done. Any doubts? Yeah, seriously, you people are having a lot of patience. Okay, great man. But you should get advantage. You are spending time in the sense, whatever the doubts you are having, it should be cleared in the class itself. Okay, so no need to worry about the content and all. So we can do a lot of groundwork and all. So, but only thing is you need to attend the classes regularly. So I will be solving all previous year questions, and then so in online now we can discuss more extra questions. Okay, so and then we will be giving some practice questions to you people. You need to solve, and parallelly you can do some test series and all. Okay. Any doubts? Any doubts so far?
Please so ask. Tomorrow is tomorrow same timing, sir.
Same timings. Is it comfortable to all? Anirudh? Is
yes,
it this time is comfortable to you people? 8 to 9:30?
Yes, sir.
Sai Charan? Rishika? Shanmugapriyan? Rishika? Yes, comfortable, na?
Yes,
okay.
Sir.
Okay. Attend all the classes. Okay. Slowly, I think they will be sharing this PPT to you people, but you can prepare your own notes. That is good idea. Then you won't feel bored. So if simply watching the video, you will definitely feel bored. Okay. If you start writing the things, then you will feel comfortable in the class. Okay. This is just introduction class. Okay. Tomorrow we can start with system of forces. Thank you. We can meet in the next session. Okay, now?
Thank you, sir.
Okay, done. Thank you. Good night.
Thank you, sir.
Good night.
Sir, one more thing, sir.
Oh, tell me. Sorry. Sir,
how many classes we have in a week, sir? In a week, how many classes, sir?
Actually, you can talk to Sir. I think Sir has given schedule, right?
Yes, sir. Today and tomorrow is at the schedule, sir. Today and tomorrow.
Today and tomorrow only. Today?
Yeah. And tomorrow.
Tuesday,
tomorrow and then 9, 10, 11. 1 minute, 1 minute.
3, 4. 3, 4.
And then 9, 10, 11.
Yeah. Then regarding this, I think Sahara has given schedule. Accordingly, we can go ahead.
Okay, sir. Thank you, sir.
No need to worry. I think parallelly, I think this is your first class, huh?
What's in engineering mechanics, sir?
Yeah. Online. I think this is the first class for you people, right?
No, I think previous year I attended strength of mechanics and industrial engineering, sir.
Oh, great. Fine. Yeah, okay, slowly, I think you will get to know.
Thank you, sir.
So what here idea is what extent we covered in the class, you need to complete it. You need to solve all the problems. Then I think your syllabus will be completed on time.
Okay.
Parallelly, practice will be over. Okay, done. Okay, any queries now you can ask sir. Okay, sir. So they know better. Okay, done.
Thank you, sir.
Thank you. Thank you. Good night.